This lecture will cover unit conversions, which unit is a measurement of some substance, some way of measuring it, and often you have to convert between two different units. So this will be the math portion of how to do that. Here are some key concepts that we'll be going through. First, we're going to look at some base units that'll pretty commonly show up, and then also some metric prefixes, and I'll explain what those mean. But you're familiar with them, things like centigram, like a centa, kilo, milli, like millisecond, those prefixes that come before the base unit. Now we're going to look at something called a conversion fraction, and what you're going to need to do is explain how those can be used to convert between units. And then the last one is really where we're going to spend a lot of time in it, and it's on the math portion, which is converting between two SI, that's the International System of Units, and using this method called dimensional analysis, which you may not be familiar with, but you'll learn how to do over the course of this lesson. So here are some common metric units and then their prefixes. So the base units are on the left-hand side, and these are used to measure certain qualities. So like meters is used for length, and grams is used for mass, and seconds is used for time, and liters for volume, and joules for energy, and calories for energy also. Those are some of the common ones that we'll be using this year. Not all of them, but those are some of the common units. Now, sometimes there's really, really, really big numbers or really, really, really small numbers. And so dealing with huge numbers and lots of zeros can be a little bit difficult. So prefixes are used to make the numbers a little bit more meaningful. So over here, you'll see the word, kilo is a prefix that means that it's 10 to the third, or that's 1,000 times larger than the base unit. That's the most common larger unit that we'll have. There's others. There's mega, which is 10 to the sixth, or a million. There's a giga, which is 10 to the ninth, which is a billion times larger than the base unit. Then moving down where it's smaller, centi is 100, like a century. Centi would be 100 times smaller than the base unit. So for example, there's 100 centimeters in 1 meter. And then the other two small ones that we use somewhat commonly in this class at least are milli and micro. Micro is a millionth of whatever the base unit is. So like a microgram, there's a million micrograms in 1 gram. So those are the units, and those are good enough, but every once in a while you're going to have to convert between them. Now, I don't say this with any type of hyperbole or overstating it. This really could be one of the most important lessons of the year because it leads into so many others in chemistry. There's a lot of chemistry that deals with units and converting between units and finding ways to get from, say, one unit to another. And it is really, really important. And that last bullet point there, it all starts with some heavy math. That is sarcastic because here is how it starts. If you can get this in your head, you're going to go a long way towards doing well on unit conversions. If you understand that 1 equals 1, that's a good thing. So now from that we can sort of have some logic. 1 meter equals 100 centimeters, and I put that 10 to the second there in parentheses. So this is called a conversion factor. These are two different units, a meter and a centimeter. They're two different languages really, but these numbers tell you a way that they can be equal. So 1 meter equals 100 centimeters. It's a way that, again, that two different languages can be equal to each other. It's almost like a Spanish to English dictionary or Italian to English dictionary, something like that. It's a way to convert between these two units. So if you were to do something like this, if you were to take two things that are equal and set them over each other as a fraction, they equal 1, right? So 1 meter equals 100 centimeters, or 10 to the second centimeters. So then that would equal 1, right? Because when the top equals the bottom of a fraction, it's equal to 1, like 4 over 4 equals 1. Likewise, you can invert the fraction. So you can do it this way or the other. It still equals 1. It's all the same. Now, this is where the mistakes happen. The top actually has to equal the bottom. So to be a valid conversion, to be a valid a valid way of going between units, it needs to be an equivalence. So the numbers that you use need to be carefully chosen so that the top does equal the bottom. And again, this really is the most common mistake. You got to ask yourself the question, does the top equal the bottom? So some logic on conversions that is just quite beautiful, I think. So we'll get to a little bit more complex math here. 2 equals 2. Now, what would 2 times 1 equal? Of course, you would probably say 2. How about this? 2 times 1 times 1 times 1. What would that be? Still 2, right? So, do unit conversions change the value? No. This is an important point. When we're using unit conversions, right, this 1 here is almost, it's like we could do that as a conversion fraction, like, 100 centimeters over 1 meter. We're not changing the value, we're just changing the language. And we can change the language multiple times if we need to get to some other answer that might be, it's going to equal the same as the original, it just is going to be in a different language, a different unit. So before we get into it here, you need to make special note. The conversion fractions must equal 1. The top must equal the bottom. And so you need to ask yourself that. Every time you make a conversion fraction, you need to ask yourself, does the top equal the bottom? And if you don't know, you need to look it up. You need to find it in a book or find it in your notes, because that really is the key. If you can answer that question correctly every time, you will get every of these problems right. It really is that straightforward. So let's get to it here, unit conversions. We're going to do a sample problem, and I'm going to take you through it sort of step by step, and I'm going to have some written up directions for you. And so I'd say write both down, the sample problem and the directions, kind of like a procedure for doing these. So the problem, I'll go back here, convert 10.0 millimeters to meters. So if we were to ask this as a question, it would be, how many meters are in 10.0 millimeters? So here's your procedure. First, you write the number given in the problem. It's really that straightforward. You got to find a place to start, so you write it. Just like that. Now notice I put the number and the unit. So maybe in your little directions here you might want to say write the number and the unit given in the problem, because that's key. Next, this is where it might be a little new. You need to draw what is called a T-chart, and you put the unit to cancel on the bottom. The unit to cancel is going to be the one that you started with. And then number 3 is going to come up also here. Put the desired unit on top. The desired unit is the one that you're trying to get to. So in this case, the old unit, the one to cancel, is millimeters. And then the one you're trying to get to is meters. So here's what this looks like. That there is called a T-chart. There's a lot of other little names for it. But yes, it's called a T-chart. Now this is a way of representing a fraction. And so you need to see this line here as a fraction line. We have a numerator and a denominator here. This is like a multiply here between the two. So it'd be, this is on the top side. It'd be multiplied by this number. Any number down here gets divided by. So let's get back to our steps. We wanted to cancel millimeters on the bottom. We put the desired unit on top. Now, these numbers here, you choose based on what makes them equal, right? The top needs to equal the bottom. So 1 meter equals 10 to the third millimeters, or 1,000 millimeters. That's that prefix that we were looking at earlier. There's 1,000 milli of anything, really, but in this case it's millimeters in 1 meter, the base unit. Okay, so 10 to the third is milli, and it's 10 to the third smaller than the base unit. So now, because there's a unit on top and a unit on the bottom, and this is a multiplication, these are treated kind of like variables, so you can actually cancel them. It's like if you had an x on top and an x on the bottom in, say, a math class, you would cancel those. So the next step is kind of, in a way, the done deal, just you're getting to your final answer. Any numbers that are in the numerator get multiplied, and then you divide by any numbers in the denominator. You got to make sure to cancel the units properly. And so what you would get here is 10 to the negative 2 meters. So what it would look like is 10 times 1 divided by 10 to the third. Or it would be 10 to the 1 divided by 10 to the third, which equals 10 to the negative 2 here. And we're going to do a couple of more examples that show this a little bit more clearly. If you did it in like a calculator or something and you had a fraction, right, you'd be looking at 0.01 right now, 0.01 meters. So this method of solving problems we need to become familiar with. Now right now you might be thinking, I could have done this a lot easier and saved a bunch of time if I just moved the decimal place over, right? And I learned how to do that like in junior high, move the decimal place over 3 places. And that does work for a problem like this that is quite simple. What we will be getting to are types of problems where you can't just say move a decimal. It's not always going to be based on, you know, units of 10 or something like that. So this is a method of thinking. It's a method of converting between units, a method of changing the language, if you will. You have to get this problem down, and it would really set you back if you tried to take shortcuts here and not learn the method just to get the answer right. This is really all about process. So let's do a sample problem, and I'll take you through it, but I might recommend you pausing it and doing it yourself. So here we go. How many kilograms are in 5.0 grams? If you're ready, go ahead and pause the video and give it a shot. Otherwise, I'll be taking it through in just a few seconds. But pause the video if you think you're ready. So here we go. The first step, if you look above and wrote those down, the first step is write the number in the problem. Boom. Easy. 5.0 grams. You write the number and the unit that you're given. Then you do the t-chart. This is your fraction that you're setting up. The unit that we want to cancel is grams. The unit that we want to go to is kilograms. So they set up this way. Grams go on the bottom, kilograms go on top. The numbers that make this true, meaning that the top equals the bottom, is 1 kilogram equals 10 to the third grams. So units canceled properly because there's a grams on top and a grams on the bottom. Looking at the numbers here, they would be like this. 5.0 times 1 divided by 10 to the third. Now when there's an exponent in the denominator, it's a negative. So the final answer in proper scientific notation here would be 5.0 times 10 to the negative 3 kilograms. Now notice the unit here. This is one way that you know you've done it right. If the dropping off unit here, the last unit that you have in the numerator, is the one that you were asked for in the problem, that's, you know, you've done it the right way. So this kind of gets transposed or rewritten over here as the unit for your answer. But you got to look here. If you have the wrong unit here, you've set up the problem incorrectly. So I have a tip for you when you're not sure which numbers to put where. A smaller unit, so a unit that is smaller than the base unit, is going to get the bigger number because there's more of those that fit into the base unit. Likewise, if there's a larger unit, it's going to get the smaller number. And I'll show you, I'm going to go back and show you what I mean. Notice how a kilogram is a big unit, it gets the small number. Grams is smaller than this, so it gets the bigger number. Big unit, small number. Smaller unit, bigger number. So, small units, large number, large units, smaller number.